Hey everyone, welcome back. Today we're diving into another real-world vulnerability that I've turned into a hands-on lab. In this video, we'll explore a weak password reset token flaw that leads to a full account takeover. We'll build a vulnerable web app, exploit it step by step, and then we will fix it. Now, this lab is based on a real finding published on System Weakness by a security researcher, Aswin. This is his profile. I reached out to him, we connected, and then I recreated the vulnerability. So, huge thanks to Ashwin for sharing his discovery and collaborating on this project. I'll leave links to his original article and his profile in the description. And by the way, I've customized the channel a bit. I changed the name and updated the description. Let me know what you think about the new look and let's get started. So, what exactly is the bug? In Ashwin's article, he found that a platform used a JWT token for a password reset. The token contained only the user's ID, was signed with a weak secret, and had no expiration. And worst of all, the user IDs were sequential. So, an attacker could get reset token for their own account, crack the secret using a dictionary attack, forge a token for any other user ID, like admin, and then reset the user's password and take over their account. This maps to OWASP A072025 authentication failures, specifically CW287 and CW303. Now, theory is good, but seeing it in action is better. So let's open our editors and build a vulnerable version of this app from scratch. I'll be using Node.js for building this application. I'll start by initializing a Node.js project. Now I'll create this file. So here, first of all, we need to import some libraries. Now we'll require some users. So for this, we won't be using database as if we integrate it, then the project will get too complex. So instead of using the DB, we will use in-memory user store. So basically that will be a list in which we'll be pushing the users. And whenever we use the password reset feature, we will also be able to reset the password of that particular user within that list. And also we'll need a JWT secret, which we will also define here. Now, when we will start the lab, these entries will first get pushed into this users list and then we can see them in the terminal. Here you can see we are using next ID to fulfill the test case of incremental ID, which we have already seen in the article. Now, we'll write some helper functions to identify users via their email and ID, which we will use in other functions later. Now I need to code the login page and the login route to check the accessibility of the users. That is, once these users are pushed into this list, then we'll need to check if we're able to log in via the email and password so that we can later on check that the account takeover is actually working. Our login functionality is ready. So after the user provides a correct email and password, then this JWT token will get generated and then the user will get redirected to the dashboard page and will share the token in the GET request, which is not recommended in real world applications. But here for this lab, we're just doing it to check the accessibility of the user, as I've already mentioned. The scope of the lab is how we can modify a password reset token to take over an user's account and not post login exploitations. So for that reason, I'm just using this to check the accessibility of the users. So now let's just define the dashboard. The dashboard page is also now ready. Now we'll start with the forget password functionality. Our forget password functionality is ready. So a user needs to provide their email into this forget password page, and then the server will check if a user with this email exists, and if yes, then the reset token will get generated and it will be logged onto the console. Then we'll get this message. Here, the format of the reset link is exactly the same as Ashwin mentioned in his blog. So if we see, the password reset link was divided into two sections, token 1 and then token 2. Though I clearly don't understand what is the use of token 1 here, but the payload contains the token. And then there is a UTM source parameter, which is basically for checking the source of the link, that is through which medium user has received the password reset link. So now let's code the password reset functionality. So after the user clicks on the password reset link, then the user will land onto this page. Here, the payload will be fetched from the URL and it will be stored in a hidden input field and then will be shared via post request. Then this payload will be verified with the JWT secret. Then the payload, that is the JWT token, will be decoded and the user ID will be fetched. And if any user with that particular ID doesn't exist, then this error will be generated. And if the user exists, then the password will be reset. So now let's check if everything is okay or if we're getting any error. So before that, I'll just point it to the login page directly. Now open the terminal and install the required libraries. Now let's start the server. So we'll be seeing a basic login page here and we have 3 seated users. So let's check. Now let's log in with our attacker account. So here you can see we have our dashboard, attacker example, the token. Again, this is not our scope, so I'm just keeping it like this. After the lab is published onto GitHub, take this as a task and fix this scenario. Make this dashboard page secure. Remove this token and handle it in such a way so that it becomes secure. And then push it back to the repo. If the code works, then I'll merge it. Okay, so now let's go to our forget password page. Here we'll provide our email. Okay, a link has been sent. Now if I just click on it, okay, we're getting a secure connection error. So let's just check it. Here you can see we've provided HTTPS. So I'll just hit it back with HTTP. Now we've got our password reset. And now if I just reset my password with 123, our password is now reset. Now let's try to log in again. Okay, we're able to log in as an attacker. And here, let's just do one more thing. Right when we reset the user's password, I want to log back the users list so that we can see that the password actually got changed. So we can do that here. Now, let's just restart. Go to the login page, provide the attacker's credential. Okay, now let's go to forget password page, provide the mail, reset token is being sent. You can see now we have in HTTP. Here we'll set it to hello@123, reset password. Here you can see our attacker's password got reset. Now, if I go back to the login page again, so we're now able to access the page. Now, let's proceed to the exploitation part. So here, if you see, the attacker generates a password reset link and analyzes the token. So let's do that. We'll copy this link into a text file. Now copy the token and we'll analyze it in jwt.io. We just have the ID parameter here, and also we won't be able to edit it because if I do and try to use it here, then here you can see I'm getting an invalid token message. So for this, I need to first identify the secret key. So to achieve this, Ashwin used the tool JWT Cracker, though there are multiple other tools and you can use any one of it. And if you want to follow with JWT Cracker, then you can find the GitHub link here. Here's the installation step. You can follow it. I already have it installed. So I'll just show it to you by running the command. So let's just go back to our editor and try it. So just copy the token and open the terminal and type this command. For understanding the flags, you can refer the Git repo. And if you execute, then here you can see it found the secret. Since we have hard-coded a easy secret, so it found it in just 0.35 seconds. And we've used the word list RockU, but Ashwin used a word list of his own. So now we can just use this secret to modify the token. Okay, it says invalid signature, so I'll just copy the token again. Here you can see valid secret, the data. Now change this tree to, let's say first we'll change the first user, and we'll copy this string now. Just modify this payload. Apart from this, keep everything as it is. And if I open it, you can see we got something. Let's just change it to hacked reset password. Okay, now if I go to the terminal, then here you can see we were successfully able to reset the password for user 1. So now if I use this scripts to log into the user's account, then I'll also be able to do that. So here you can see we are now able to access the user 1's dashboard. So that's the attack in a nutshell. The app trusted a token that was trivial to forge. Now let's look at how we can fix this properly. I'll create a separate file for it to keep the vulnerable code and the fixed code separate so that I can share it with you. So now we will no more use JWT for password reset tokens. We remove JSON web token from the password reset logic and use Node's crypto module to generate cryptographically secure random tokens. So first, let's just create a separate file for the fixed code. Just remember, if you fork this lab from GitHub, then just point this file to the one that you want to use. So now we need to import the crypto library first, and we'll also install it. So now you might also think that the same token is used in the dashboard, even though if I fix the password reset token, then the dashboard will still be vulnerable. So for this, I already have a video on my channel regarding how you can harden and use JWT in a secure way. You can find it in the I button, just go check it once. Okay, so now the goal is we'll first generate a random cryptographic token which will hash and store in the memory, just like we have stored our users. But this token will be a one-time token. So basically, once you reset the password, then the token will get deleted from the memory. So let's create the storage first. Here, this map stores hash tokens with their associated user ID and expiry. Now let's write a function to generate the tokens. Now we'll modify this forget password function. So first, the token will get generated, then we'll hash the token before storing, and its expiration time will be for 15 minutes. And then we will map the user ID and the expiry time with the token hash. After this, in the password reset form, we'll also have to modify the logic because here we won't be receiving the JWT secret now. So I'll just remove this try catch block. And here, let's just call it token. And here we'll receive the token. And okay, so here you can see first after receiving the token, we are creating a hash of it, and then we are checking if it exists in the storage. And if it does, then we're fetching the user ID from it. Then accordingly, we're just showing the form with the token value hidden in the input parameter. And now in the password reset token also, I'll just remove these blocks. So the same exact thing here. And now let's check if it works. Now let's go to our forget password page, reset password. We got our link. So here you can see now it's the token. let's print the storage when the token gets generated. Now let's restart the server, copy the email, go to forget password. Okay. Okay, I'll have to set it reset tokens, not reset token. Again. Okay, here you can see the token gets generated, and this is how the token gets stored into the storage. Now, if I open this password reset token, and here, if I'll just type hello, reset password, password has been reset successfully, and here you can see I'm getting the password again. Now, let's try to access this token again. Okay, I'm able to use it. That means I didn't delete the token after it gets used one time. So I'll just fix it. Now, let's save it and rerun it. Now we've reset our password. Let's try to reset it again. So you can see we're getting invalid or expired token. Now let's see by generating multiple tokens by multiple users. Here again, reset password. Again for user 1. Now again for user 2. And here you can see 3 different tokens got generated. Now let's use one of the tokens. Now I'll change the password to 1234. And here you can see this got reset. Now this one, you can see this one also got reset. And let's just check if this tokens got deleted from the storage or not. So here you can see we have 2 tokens. That means the previous 2 tokens got deleted. This lab is a perfect example of how a seemingly small oversight can escalate into a critical account takeover. I hope you enjoyed the coding along with me and learned something valuable. A huge thank you again to Aswin for discovering this and allowing me to turn it into a learning resource. Go check out his article on system weakness. Link is in the description. If you found this video helpful, please like, subscribe, and hit the bell so you don't miss future episodes. I've got more real world vulnerabilities lined up, and I've been collaborating with more researchers. Some involved IDORs, some SQL injections, and some RC, and even few race conditions. I'll be coding them live just like today. Also, I'd love to hear your thoughts. Have you ever found a similar bug? What other vulnerabilities would you like me to cover? Drop a comment below. I read everyone. You can find all the code from this video on GitHub, both the vulnerable and the fixed ones. Link is in the description. Fork it, break it, fix it, and let me know how it goes. And additionally, I'll also post a Medium blog, which I'll also link in the description, so you can also check that one out. So thanks for watching, stay curious, and as always, stay secure.